So hello everyone. I am Mom Kim. Welcome to General Physics 2. Again ha, I am Mom Kim. Please call me Mom Kim. And today we're going to learn about electric flux. So before going through that, let's review muna electric field, which I believe was the last lesson you had last quarter. So electric field is so it actually exerts force on all charged particles it encounters. So let's go muna to the positive charge. So a positive charge, ayahang actually force, ang force niya is actually going out of the charge or pushing. Yeah? So pushing, so going out siya here. And for a negative charge, it's pulling. So therefore, the electric field is going to the charge. This is actually the kaning directions nila guys. This is actually the reason why opposite attracts. Why a positive charge and a negative charge can attract each other. Because if you can see the arrows and the positive going out and then the negative receives. So iyelahan lang na siyang one direction lang dayon ang direction sa ilahang electric field. Therefore, they can go together. They can attract. But then, if I put a positive charge here, which is pag-go out, di ba, ang iyahang electric field, of course, if you can see the arrow, magbangga sila. They're actually going through the same direction or kanang they're actually both pushing rather, sorry. They're both pushing. That's why they repel each other because they push each other. Manang dili go work out mga relasyon is toxic kayo. Okay. So, let's have this situation, no? Suppose that there is an object in front of a charged particle. So, this is a positive charged particle. So, kani siya, ato ang object. Now, the electric field goes through the surface of our object. Remember ha, only through the surface and not into the object. Not into the object. Dili sulod sa object but only in the surface. Again, ang atong electric field lines go through or flow through the surface of our object. This is what we call electric flux. So, let's have another example. So, suppose that we have a school of fish. A school of fish means a group of fish swimming together and they are in one direction. So, you can see, no, that they are swimming in one direction, diba? And they are lining. May pa ang fish galinya. So, let's then put a blue screen or a flat blue net in front of the school of fish. So di ba of course, naamang makot nga mga fishes sa atong screen. Here, muna mga fish nga na-catch sa atong screen. So the number of fishes nga nasulod sa atong blue screen is actually the same number nga electric field lines of our electric field lines na mo pass through sa surface sa atong object ganina. So this is what we call electric flux. So let's again have. So electric flux is the amount of electric field lines. This is the amount of electric field lines that passes through the surface. So let's suppose this is our charged particle. So these lines here are our electric field, kanatong electric field. So and then the number of electric field lines that passes through this object or through this surface is what we call our electric flux or flux. Okay? So, let's have this one. So, if you have more charges, therefore, there are more electric field lines. Therefore, more flux. Kaya mas daghan man ang mo aging electric field lines. Kaya daghan man electric field lines. But if you have less charge, therefore also we have less electric field lines, which also means less flux. So directly proportional to each other ang atoang charge and the number of flux. So let's have this equation, no? So electric flux, to properly define electric flux is actually the rate of flow of electric field through a given area. It's not necessarily nga ang electric field nato ga-flow like water. But it's more like itong beam of flashlight. It's more like nag-flashlight kapag on mo sa flashlight, 'di ba ang beam nimo kay straight lang siya. It looks like flowing but it's not really flowing. Inana lang si electric flux or si electric field. So we have here this equation. This is phi is equal to E. E is our electric field times A, which is our surface area or area. Surface area or area. Surface area, we're going to talk about surface area if 3D objects na. Pero kung 2D objects like this one, this is a 2D object, flat naman siya. It's just area. And so, our unit will be Newton times meter squared per coulomb. That will be our unit for electric flux. Okay. Okay, so let's have an example. So have you taken note of the formula? So let's have an example. So a uniform electric field E is 8,000 Newton per coulomb. This is Newton per coulomb ha. Passing through a flat square area which has an area of 10 meters squared. So example, I have a flat square area here. And then ako daw electric field, nagpass through daw siya here. So that's our illustration. So what is our electric flux? So this is what we usually do sa akong klase, what we're going to do in tackling problems is we're going to write the given, what is asked, the equation used, and the solution. So let's first state the given. So our given is the electric field is 8,000 Newton per coulomb. Our area is 10 meters squared. What is asked? We're looking for the electric flux or the phi. And of course, what is the equation that we need to use? The equation we need to use is phi is equal to E times A. So the solution, let's just substitute the values. Okay, so E is actually equal to 8,000 Newton per coulomb times 10 meters squared. So let's just multiply 8,000 times 10. Therefore, it will be 80,000 Newton meter per coulomb. That will be our final answer. And don't forget to box your final answer. So, yun rin na? Okay, so let's have another example. Problem 2. So, a uniform electric field E, 2,400 Newton per coulomb, passing through a flat, remember always guys always remember unsa ang shape sa ato ang surface. Why? Because we need it to determine the area. Example for this problem. A flat rectangular surface with a length of 4 meters and the width of 12 meters. Determine the electric flux. So let's state the given. We're given the electric field 2,400 Newton per coulomb, length of 4 meters, width of 12 meters, and then what we're asked? So we are asked of the area of the rectangle and the electric flux. Ma'am, ngano mangita pa man ta sa area of rectangle? Because remember, the equation that we need to use is, so wala pa na ako na state here, no? Equation to use is phi is equal to E times A. Now we have no A. That's why we need to find out muna the area of the rectangle. Now, this is the reason why I told you to always take note unsa ang shape sa ato ang surface. Because then we will know our area. Okay, kung given lang ang dimensions. So, ang dimensions sa ato, ang length to kuno kay 4 meters ug ang width kay 12 meters. So, how to get the area of the rectangle? A is equal to length times width. Right? So, therefore, it's just 4 meters times 12 meters. Pila man na si 4 meters times 12 meters? 4 times 12 is equal to 48 meters squared. So, nanatay area. Since we already have our area, now we can get our electric flux. So, substitute here, phi is equal to E, 2,400 Newton per coulomb times 48 meters squared. So our phi will be 115,200 Newton meter squared per column. Don't forget to box. Okay? So let's have another problem. Daghan na itong problema, ma'am. Yes. Okay. Find the electric flux given that an electric field of 470 Newton per coulomb passes through the square with an area of 16 meters squared as shown in the illustration below. Now, this is actually another situation. Kanina, the situation was that the area was not given. Mo nang kinahanglan to paytaon si area first. Karon is nanatay angle. Ma'am, nga nang natay angle. Saan man nato ni? So let me explain first the illustration. Kaning blue line here, if you see the blue line, that's actually our normal line. Again, what is that? Our normal line. Now, what is unsa din ang normal line, ma'am? So, normal line is actually the direction where our surface is facing. So, si normal line is actually the direction or it indicates where our surface is facing. So, for this problem, for this image, no, ang atong surface kay ga-face up there, here in this area. And these green lines here, these are our electric field lines. And so, therefore, the 60 degrees here is actually the angle between the normal line and our electric field. Then, since na naman tayo angling, of course, kay ganina manggod, ang ato rang gi-assume is that straight lang gyud ang ato ang electric field line o kung asa pod nag-atubang ang atong surface. Karon is that naanay difference ang ato anang dili naghiwi na gamay ang atong surface in comparison or relative to the electric field. Therefore, we already nanaden tayo bag-o nga formula. Please take note of this new formula, which is phi is equal to E times A, electric field times area, times cosine theta. Now, remember, the theta here is actually the angle between, angle between the normal line and the electric field line. So again theta is the angle between the normal line and the electric field line. Okay, please take note of this because this is very important. So, okay, so this actually, so mo man itong discuss kanina, no? This is the new formula that we're going to use. And this is the normal line. Again, what is the normal line? The normal line is the direction where our surface is facing. And our theta here is actually the angle between the normal line and the electric field line. Okay, please pasensya sa akong PowerPoint. Okay, so let's tackle the problem now. Now that we know what equation to use. So let's first state the given. Of course, the given is E, 470 Newton per coulomb, area of 16 meters squared, theta of 60 degrees, and electric flux. So what we're asked to get is the electric flux. So wait, sorry. Of course, what we're going to do, so theta is equal to E times A cosine theta. Phi din I'm so sorry. Phi is equal to E times A times cosine theta. So just substitute the values. Our E is 470 Newton per coulomb. A is 16 meters squared. cosine 60. Always use cosine because this is in proportion to the horizontal line or to the x-axis. Therefore, our phi is equal to, okay, even though that you're only watching this video, please calculate also. So, pila? My answer here is 3,760 Newton meter squared per column. Okay, do we have the same answer? Of course, this is a recording. You cannot answer me. So you just comment down. Char lang. Comment down on my video, subscribe, and click the like button. Oh. Okay. Sige, let's proceed. Question. If you have any questions, please do not hesitate to comment. Okay. Let's proceed to the... okay, let's proceed here. So let's explain muna no, the different orientation of our surface or our normal line. So the first orientation is kani. So the blue lines here are actually our electric field. Kanang blue lines sa E-field na to na. Kaning circle here, that is our surface. Kaning pink nga arrow is our normal line. That's why the N. That's N. That's normal line. Okay? So, if ano siya ha, if our normal line is parallel to our electric field, again, normal line is parallel to electric field, therefore, atong theta is 0. This is parallel. If our normal line is parallel to our electric field, therefore, we have, atong gamiton aning formula is just phi is equal to E times A. Ngano mang walay cosine, ma'am? Because since the angle is 0 or the theta is 0, cosine 0 is actually equal to 1. So E times A times 1 is just equal to EA, right? So this is the formula we're going to use. Now, how about this one? We already have an angle. So, ang atong normal line is 30 degrees. The angle between our normal line and our what they call this, our electric field is 30 degrees. Therefore, what's the formula we're going to use? Phi is equal to E A cosine 30 or cosine theta. This one, the same thing. Phi is equal to E A cosine theta or cosine 60. Kani, dire na punta. Our normal line is perpendicular to our electric field. So this is perpendicular. Therefore, our theta is 90. Since they're perpendicular, therefore 90 degrees ilang angle between each other. This one, ilang angle here or ilang angle here. Therefore, cosine 90, if you put that in your calculator, is equal to 0. Since our normal line and our electric field is perpendicular, therefore cosine 90 is equal to 0. If we're going to do that in a formula, phi is equal to EA times cosine 90, 0 times EA is equal to 0. Therefore, automatically, if ang ato ang normal line o ang atong electric field is perpendicular to each other, our electric flux is 0. Okay? Again ha, kung perpendicular sa normal line o si electric field, the electric flux is 0. Nganong 0 man, ma'am? If you can see here in the illustration, just imagine no, na this is water and this is kanang mo siya circular basin. Of course, nakatakilid siya. Makasulod ba ang water ani nga basin? Dili. Kay, nakatakilid gud siya. Walay makasulod nga water. Therefore, there is 0 flux. If you notice the trend, no, as you go higher sa imong angle, magkagamay imong electric flux. But as you go lower sa imong angle, magkadako imong electric flux. Therefore, if at the highest angle or theta that will be 0. Then if it is at the lowest, which is 0, ang atong theta or atong angle, therefore, our flux is at the maximum. Okay? Okay. Okay. Now, we were talking about the electric flux in uniform surface. Ano meaning sa uniform surface, ma'am? Katong ganina nga atong gi-example. So, uniform surface is that we just have a flat surface. Uniform surface meaning we have a flat surface. But right now, we're talking about non-uniform surface. Meaning sa non-uniform surface is that 3D na ang ato ang surfaces. Dili na siya flat lang square, kundi na natay cube. O dili lang circle, kundi na natay sphere. Like this. So this is, okay. Now, how do we get the flux in a non-uniform surface? So, actually, what we're going to do, the formula for this is actually phi is equal to the integral of E electric field times dA. Now, if you remember your integral, we know that constants kay itong ipagawa sa integral. So, let's define muna asa ang constant here. So, ang constant actually ang atong electric field. Ma'am, nga nung constant sa electric field? Because the electric field here is just equal to the electric field here, here, and here. So, in every area of the sphere, in this sphere, ang electric field is just equal. Therefore, our E is constant. So, kay E man siya, ito siya ipagawas, I mean constant E, integral of dA. Now, how the integral A? It's just A. So, therefore, we have A. Ma'am, pariyara mong guna ganina, ma'am. Uy. Actually, yes, this is just the derivation of derivation ra nato ni sa integral no fra sa sa non-uniform surface. So, but actually, kani siya nga formula will actually lead us to Gauss's law. So, we're not yet finished in kuan ha. Sorry. Please excuse me. So, we're not yet finished with deriving. We're not finished yet with the derivation of our non-uniform surface. So, naa pa day, ma'am? Dagan pa day ni? Yes. Okay. So, let's wait lang for a moment. Okay, wait for a moment lang ha. I know that this is a recording and I should have been ready. But yeah, why not? We are recording and I'm not ready. Okay. So, we're not yet finished ha with so this will be phi is equal to E times A. Now remember, what is the electric field of a sphere? Kaniha, what is the electric field? What is the formula in getting the electric field of a sphere? It's actually E is equal to Q over 4 pi permittivity R squared. And how do you get the area or the surface area? Surface area of a sphere is actually 4 pi r squared. And we're going to substitute this equation here. So, phi is equal to Q over 4 pi permittivity r squared times 4 pi r squared. We can cancel 4, we can cancel pi, we can cancel r squared. What's left? We have phi is equal to Q over permittivity, wherein permittivity or epsilon 0 or epsilon sub O is equal to 8.85 times 10 to the power of negative 12 coulomb squared per Newton meter squared. So this is a constant. So this is our this is how we get the electric flux of a non-uniform surface. Taasa ma'am, uy, inani pata, char lang. That's actually the derivation. So, this equation then will lead us to Gauss's law. So, Gauss's law states that the net flux through a closed surface is equal to Q over permittivity or epsilon sub O. Katong nakuha nato ganina nga equation where Q is the net charge entrapped in that closed surface. So again this means that if we have kuan here a charge, it is actually ang Gauss's law talks about. Wait lang guys. Hi BB. Wait BB wait. So our kuan, sorry, going back. So um our charge is actually enclosed in a surface. So, unsa daw kano ang ato ang net flux, kumbaga ang net flux, ang mga flux nato sa ato ang enclosed surface, sa surface nga nag-enclosed sa ato ang charge, what is the net flux? So, magkuha nato ni through this equation. So, this was developed by Carl Friedrich Gauss. Okay. Pasensya is ginan you guys. So this was muna siya ang electric field no, the electric field of a sphere. Why sphere man ma'am? Sphere siya because usually si Gauss surface or Gaussian surface is actually mostly in the shape of a sphere. So this is our kuan. So again Gaussian surface. Saan ang Gaussian surface, ma'am? Ang Gaussian surface, okay, I'm really sorry about this. I don't know how to fix this. I tried but could not. So Gaussian surface is an imaginary surface that we assume, assumera, around the point charge. So if I have a point charge, pas ganina nakita ninyo, the surface that surrounds it or the sphere that surrounds it is actually our Gaussian surface. And that's actually just an imaginary surface. Why do we have to imagine? In order to calculate unsa di ay ang flux sa atoang net flux sa atoang charge, which is the discharge, right? Okay, again Gaussian surface is the imaginary surface nga nagbalot it covers na nag-cover around sa atoang charge. This is the imaginary surface that covers our charge. That's the Gaussian surface. Now, what if our charge here, as seen here, our charge is outside the Gaussian surface? This is our Gaussian surface. What if our charge is outside the Gaussian surface? Therefore, our electric flux is 0. Nganong 0 man, ma'am? Because as you can see in the formula, Q enclosed, the charge of the enclosed particle. Meaning, ang charge daw sa particle nga nasa sulod sa Gaussian surface. Nanamo siya sa gawas, wala siya na enclosed, therefore 0. Kaya wala man siya na enclosed. Simple. Char. Okay. So, this one is, saan din na siya, ma'am? This is our Gaussian surface, right? This is the imaginary surface around our particle. What we mean by this part, kading darken nga part, that's actually what we mean by dA or derivative of A. Wherein, di ba we know that in every surface or in every area here, our E is just equal all over. So therefore, magkuha na tag sample from our surface, magkuha na tag gamay nga sample in order to get our electric flux. Ma'am, nganong gamay ra nga sample? Because if we're going to calculate for everything, that will be a very long calculation. Gihimo siyang simplify by just taking a sample of the surface area. So this was actually what we did earlier. Katubitong atong gi-derive ang integral nga equation. So muna ni siya actually, guys. So you don't have to worry too much about it. So this is the general form of Gauss's law. Pero, nga ma'am, ganina ma'am, wala to circle ang integral. Nga nung karon ay circle. This means that this is the integral of an enclosed surface. Manang meaning ano yung circle. Okay? But, ito rin yung ginagamit ng formula ani kasi Q enclosed over permittivity. So, let's have this example. So, this problem is actually in your problem set, which I will be also giving. Please answer the problem set number 1 that I will be posting. And that will also serve as your practice exercises for electric flux and Gauss's law. So let's have an example muna with this. So 3 small spheres in this figure has a charge ang Q1 niya kay 4 and C means nanocolumns. Nanocolumns means 10, nano means 10 times 10 to the power of negative 9. And negative 7.80. O sige, ang nano times 10 to the power of negative 9. And Q3 is negative 2.40 nanocolumns. So, for surface 1, which is our surface 1? Our surface 1 is encloses Q1. Nara. So, unsa man natong buhatan ni? Our equation will be QE is equal to Q enclosed over permittivity, wherein Q enclosed is Q1. What is Q1? 4 times 10 to the power of negative 9 coulomb per 8.85 times 10 to the power of negative 12 C squared over NM squared. And then you get the answer. So let's have S3. How about surface 3? Surface 3 encloses Q1 and Q2 as a surface 3 here. It encloses Q1 and Q2. What do we do? For S3, it will be Q enclosed over permittivity, right? Now we have two, duha man kabuk ang ato ang charge. Therefore, we just add them. So Q1 is 4 times 10 to the power of negative 9 plus, negative na siya, plus negative 7.80 times 10 to the power of negative 9 over 8.85 times 10 to the power of negative 12. So what do we do? This is, remember lang your integers. 4 times 10 to the power of negative 9 plus negative. Therefore, mahimo na siyang just minus or negative. So, kana lang siya na. I won't answer everything because this is part of your problem set. So this is number 4 is also part of your problem set. Always remember surface of the plastic sphere. So what do you use? The surface area. Ang given lang sa mo kay diameter. So you're going to look for the surface area for your area. Okay? So this is also part of your problem set. So please answer problem set number 1. And so that's it for today, everyone. Thank you so much for watching this video. Please don't forget to subscribe. Click the like button, and see you tomorrow for our actual class with you and me, virtually face to face. Okay, so again, please don't forget to answer problem set number 1. So God bless everyone, and thank you so much for today. Bye bye.